like the one with Megan Washington make much more sense when you view language as a dynamic and widely distributed system. But before we dive in, a brief side note. For simplicity, I'll focus on spoken language in this lecture, and I'll leave sign language for another time. The similarities and differences between speech and sign are fascinating, and they deserve a lecture all their own. If we're going to talk about language production, we need to start with what prompts someone to speak in the first place. This initial spark is a bit of a mystery because it's internally generated. It's the thing in your head you want to communicate. Most of us would call these things thoughts. Thoughts are such familiar things. Philosophers have pontificated about them for thousands of years. In his famous cave parable, Plato distinguishes between superficial thoughts and deeper truths. And the great Taoist philosopher Lao Tzu urges us to clear our minds of thoughts to achieve an inner stillness and peace. However, modern-day cognitive scientists are increasingly skeptical about the conventional notion of thought. First of all, nobody's ever seen one directly. It's just a convenient construct that we use to explain things we all subjectively experience. Another problem is that a thought is typically viewed as a stable and discrete thing. But from a neural point of view, thoughts are dynamically shifting and multidimensional. Neuroscientists see thought as a distributed neural network that is momentarily coordinated in time. And this neural web links cortical and subcortical regions involved in the full range of brain function, from perception to action, language to emotion, and memory to planning. A final reason that traditional notions of thought are on shaky ground is that we don't know when it occurs. Is a thought when we're consciously aware of it, or does it exist in some form before subjective awareness? Is it just a brain state, or is it a conscious reflection on that state? Truth is, we have no idea. Still, despite not knowing what thoughts are, or when or how they occur, many neuroscientists believe that the brain generates something in advance of our conscious awareness. Have you ever heard of the readiness potential? This electrical brain response was first observed in an EEG experiment done in 1983 by Benjamin Libet at UC San Francisco. The experiment measured electrical activity on the scalp as people voluntarily reached for objects. The main finding was that a distinct brainwave, the readiness potential, preceded awareness of voluntary reaching by several hundred milliseconds. Isaac Fried and his colleagues at UCLA have since replicated this interesting finding with epilepsy patients with electrodes implanted in their frontal lobes. Using these electrodes to record motor activity involved in reaching, a distinct readiness potential appeared well over 1 second earlier than when patients reported they first had the impulse to reach. If you recall how much happens in just 1 second of brain activity, this is a pretty incredible result. Now, there's a range of interpretations of these findings. There are some, like Stanislas Dehaene, who believe that the readiness potential is the product of random fluctuations of brain activity, and this neural noise simply correlates with the overt actions of the subjects. But others make much stronger causal claims. Some have argued that the readiness potential shows that the brain knows what it's going to do well before it does it. And this has led some philosophers to question the notion of free will. I think those doubts may be a tad dramatic because they suggest an artificial dualism between the brain and mind. After all, who's to say that an unconscious neural impulse to act is not also the product of the mind's free will? In other words, does freedom to act necessarily require being aware of that freedom? That's a really hard question, and I'm not sure there's even a scientific way to answer it. But regardless of the philosophical implications, the results clearly show that some sort of unconscious neural activity precedes action. And if this is the case for relatively simple things like reaching, it suggests that for more complex actions like using language, there may be a large and clandestine neural network operating behind the scenes. Now, we don't need brain imaging to prove that thinking precedes speaking. We can learn a lot just by listening to what people actually say in everyday life. You may be familiar with Spoonerisms, which are named after the Reverend William Archibald Spooner, Don of Oxford College around the turn of the 20th century. Spooner was famous for his linguistic slip-ups. Here are a few that have been attributed to him. Instead of a loving shepherd, Spooner is said to have given us, "The Lord is a shoving leopard." And instead of "let's raise our glasses to the dear old Queen," we have "let's glaze our rasses to the queer old Dean." And my favorite, in place of a half-formed wish, we get a very unappetizing half-warmed fish. The beauty of these mistakes is that it only takes one of them to reveal that speaking unfolds according to a premeditated plan. What else could explain why parts of words that should appear later in a sentence mistakenly show up earlier? Spoonerisms are cousin to a different type of pre-planning error involving swaps of entire words within an utterance. Imagine someone saying, "Can you get some kids for the snacks?" Or, "Once I stop, I definitely can't start." No doubt we've all made these sorts of verbal mix-ups from time to time, and what's interesting about them is that they almost always involve swaps within the same syntactic category. Nouns are swapped with other nouns and verbs are swapped with other verbs, but you almost never see a noun swapped with a verb. Psycholinguists argue that these two types of speech error represent two different stages of speech planning. Exchanging entire words within a syntactic category provides a glimpse into the initial abstract stage of conceptual planning. The technical word for these pre-planned abstract concepts is a lemma, which in ancient Greek means premise. Once the lemma has been planned, the next stage begins. The second step involves putting these abstract ideas into the proper phonological forms, and it's during this step where Spoonerisms happen. One of the strongest pieces of evidence for this two-stage model is in the location and timing of the two types of errors. Because the lemma stage is so global and abstract, the swapped lexical items can span many words within an utterance, but not across utterances. In contrast, because the phonological stage is much more local, the syllable swaps are almost always between adjacent words. Hey, I bet these verbal slip-ups have gotten you thinking about the most infamous of all speech errors, Freudian slips. Are phonological and semantic errors evidence that Freud was right about the unconscious mind revealing our true thoughts and repressed feelings? I think the answer is both yes and no. No, in that most verbal slips can be explained by much more parsimonious syntactic and phonological mechanisms. Research shows that the vast majority of errors are harmless switching of two verbs, two nouns, or two syllables. Not only that, but these errors can be induced pretty easily with made-up words in completely neutral laboratory contexts. This suggests that deep-seated emotions are probably not always at play. However, this doesn't mean that unconscious emotions are never involved. Recall that neuroscientists believe that thoughts are multidimensional and contain cognitive and emotional elements. Keeping this in mind, speech errors may sometimes reveal something deeper about the speaker. In fact, researchers have come up with a creative way to test this sort of thing in the lab. In a clever experiment by Michael Motley and Bernard Bars in 1979, phonological speech errors were experimentally induced by having subjects say nonsense word pairs containing swapped syllables. For example, subjects had to repeat non-words like Ludgegs and Shad Bach, and the experimenters recorded the number of speech errors people made. And here's the Freudian twist. All of the subjects were heterosexual males, and in one condition, the experimenter was an attractive woman dressed in a skirt. In another condition, subjects had to wear fake electrodes and were falsely told that they may receive shocks during the experiment. The main findings were this. When the experimenter was an attractive female, male subjects were more likely to make speech errors related to pleasure. For example, saying good legs instead of lud gegs. But in the electrode condition, subjects were more likely to make errors related to pain, saying bad shock instead of shad bach. Now, cognitive psychologists don't need Freud to explain these findings. After all, these errors could simply be caused by a generic cognitive mechanism called priming. The idea of priming is that presenting one piece of information, like electrodes on the skin, causes a cascading spread of activation in the brain that triggers conceptually related information, like the anticipation of a painful shock. But still, even if run-of-the-mill priming explains these findings, they clearly show that linguistic planning stages involve more than just neutral nuts and bolts of language. This opens the door to a wide range of information being part of the production process. Keep this in mind because we'll come back to it in later lectures. At this point, let's see if we can get some clarity on the different stages of language production by shifting to the neural level of analysis. As we did with language comprehension, we'll start with what brain damage can tell us. Wernicke's aphasia is traditionally viewed as a problem with language comprehension, but that's proven to be overly simplistic. It's true that, on the surface, a patient with damage to Wernicke's area often appears quite fluent in speaking. In fact, if you were to listen to a Wernicke's aphasic speak in a totally foreign language, you'd have no idea there was anything wrong. It's only when you can understand what the person is actually saying that you realize something's missing. One of the telltale signs of Wernicke's aphasia is called a paraphasia. There are many forms of this. There are phonemic paraphasias, which involve missaying parts of words, like producing raggin instead of wagon. And there are semantic paraphasias that involve perfectly articulating words, but having them show up in really incorrect places semantically. So instead of saying wagon, someone may say bus or ship or even carrot.